Today, we're going to talk about rational functions, section 8.4. Okay, so continuing on with rational functions, we're going to talk about some different types of rational functions and some different types of graphing. All right, rational functions, section 8.4. A rational function can be written as a ratio of two polynomials. Okay. When we go through this today, we're going to be dealing with functions that look something similar to this. Okay. We're going to be talking about, basically, we're going to be talking about asymptotes. An asymptote is like an imaginary line that your graph is not going to cross. Okay, your graph can get as close as it can, but it will never actually cross that line. Okay. We're going to be talking about vertical asymptotes. You get a vertical asymptote at where your denominator cannot equal. Okay, so for instance, there we talk about, x cannot equal certain values. Well, x cannot equal those values because we actually get a vertical asymptote there. And then we're going to talk about a horizontal asymptote. A horizontal asymptote is where you are adding or subtracting here, basically. And then we're going to talk about domain and range. Domain and range are basically going to be the same values. It's everything but those values. As in, we can plug in anything but where those asymptotes are, because we cannot get those values. All right. So, for instance, here they give us an example here. I have a vertical asymptote at x equals 2. Why is it x equals 2? Because 2 minus 2 gets me 0, and I cannot have 0 in the denominator. Does everybody understand that? That gets my vertical asymptote. So if you look here, there's like an imaginary line right there that those graphs will not intersect at. All right? And then I get a horizontal asymptote at whatever they are adding or subtracting. So if you look right here, there is a horizontal asymptote right at -3. Okay? And basically, the graphs will never cross those lines. And then from there, we're just going to talk about sketching it. We're going to sketch what would be our hyperbola. Okay, and again, our hyperbola sketch is it's going to go up to those lines, but it's never going to cross those asymptote lines. All right, we're going to be talking about vertical and horizontal asymptotes. So let's look at number 1. I want to identify the asymptotes of each function. Then I don't really want to describe the transformation. Okay, we're not going to worry about the transformation so much. We're just going to find the asymptotes and then sketch the graph. So the vertical asymptote. My vertical asymptote, remember, is my denominator there. X cannot equal what value here? -1. So my vertical asymptote is at -1. Does everybody see that? -1 plus 1 gets me 0, so x cannot equal -1. So I get a vertical asymptote kind of right through there. Horizontal asymptote comes from what I'm adding or subtracting. Okay, so I get a horizontal asymptote at what value here, Garrett? I'm adding or subtracting. What is that value right there? So my horizontal asymptote is at -2. Good work, sir. So I have a horizontal asymptote right there. Okay. And now I'm going to sketch my hyperbola, and I get something that looks like that. How you feeling, Ibsen? Do another one? Okay. Yes, sir. Unless it's negative, it'll always be like that. Like if it's say if it was like a -1, like if it's negative up here, then they'd be like the other way. Good question. Number 2, vertical asymptote. Where would my vertical asymptote be at?
+1.
Hey, nice job, sir. It is at +1.
And then +3.
So I have my vertical asymptote right here.
Smarter than Bailey. Don't even take this class.
What about my horizontal asymptote here, Mark? Positive 3. And now I sketch my graph, and I'm going to get something that looks like that and like that. There it is. How do you feel now, Ibsen?
Still pretty dumb.
Can you find the asymptotes? That's good. You're fine.
Still
All
feeling dumb?
right. Take a couple seconds to try these two.
Yo, daily.
All right, let's look at number 3 here. My vertical asymptote would be located where, Sage? My horizontal asymptote is located where, Colin? 5. Now, it asks about domain and range. Domain means my x values. Everybody understand that? Domain is my x values. Okay. I can plug in all x values except x equals what value? What x value can I not put in? 3. So D is all real numbers, x cannot equal 3. Essentially, it is the same thing as your vertical asymptote. All right. The range. What range value will I not get back out? Anybody? 5. So range is all real, except y cannot equal what value? 5. So it asks for domain and range. That's all it is asking for there. Let's look at number 4. What is my vertical asymptote for number 4, Garrett? And my horizontal asymptote for number 4 is what, Mark?
Still trying to figure out the last one.
So the vertical asymptote comes from the denominator, right?
Yeah.
Okay. My horizontal asymptote comes from what I'm adding and subtracting. So what's my horizontal asymptote?
-1.
-1. Now my domain is all real, except x cannot equal what value, Bailey? Number 4, my domain. X cannot equal -8. And then my range is all real, except y cannot equal what value, Jack? -1. That's all it is. Nice job. All right, the next thing we're going to talk about, or last thing we're going to talk about, is we're going to talk about using the zeros and the asymptotes to graph. Okay, so when we have multiple functions here, we kind of get some different types of graphs. The zeros of f of x occur where p of x equals 0. So what happens here is the zeros, we find the zeros of my numerator. Okay, so I find the zeros of my numerator. Let's go that way. There you go. And my vertical asymptotes now are still what's in my denominator. Okay, so I'm going to find zeros. So working on finding our zeros, factoring our quadratics. And then my vertical asymptotes are still the denominator cannot equal 0. So as I look at this, they factored the numerator. Okay, we see that they're factored the numerator. And I get my zeros. My zeros come out and be -2 and 4. Does everybody understand where we get -2 and 4 at there? Okay, so what happens here is I plot my zeros, -2 and 4. And then I find my vertical asymptote. Again, my vertical asymptote comes from the denominator. My vertical asymptote's at x equals 1. So there's my imaginary line right there. Okay? And then I kind of just sketch my graph. So I'm going to sketch a graph that goes through that 0. And it cannot cross. Ooh, that's kind of a bad one there. I'll redo that one. There, it's better. And it cannot cross the asymptote line. Okay, so on these problems, I want you to find the zeros, find the asymptote, and then kind of sketch what your graph would look like. All right? So let's look at number 5. It says identify the zeros and vertical asymptotes of each function. Then sketch the graph. So number 5, f of x equals x squared minus x minus 12 over x minus 2. Okay? I have x plus 3, x minus 4, all over x minus 2. Does everybody see how they factored down x squared minus x minus 12? Two numbers that multiply to get negative 12, add to get negative 1. So they factored it down. Now, what are my zeros here? My zeros are located at what two values, Andy?
Negative 3 and 4.
Negative 3 and 4. So I plot negative 3. If I can plot it. And I plot 4. There we go. And now I get a vertical asymptote. Where's my vertical asymptote at? Bailey? Where? Positive 2, because 2 minus 2 gives me 0. So I have a vertical asymptote right at positive 2. Very good. And then I kind of just sketch that graph. And it looks like that. What about number 6? F of x equals x squared minus x minus 6 all over x plus 1. Yes, ma'am?
I'm confused.
Yeah.
I had you all the way up and up and up, but then you drew the lines. Now-
The graphs.
Yeah.
This isn't a hyperbola now. So he's kind of got to draw a curve that goes towards that line, but never actually touches that line. That's
It's not
kind of...
like specifically like touching specific points.
No.
Except the two that we made.
Yeah. Yep. So number 6 here. X squared minus x minus 6. How would that factor down? How's my numerator factor there, John? So I get x minus 3 and x plus 2 all over x plus 1. Okay. Where are my zeros located at here then, Mark? So if I look at my numerator, nope, 6 here. That's the factor. So my zeros are located at the opposites, which are 3 and negative 2. So I get 3. And I get negative 2. Okay. Where's my vertical asymptote at here, Garrett? Negative 1. Again, that comes from the denominator there. So I have a vertical line right there. Great. Now I kind of sketch my curve. Looks something like that. And something like that. There it is. Try number 7 on your own. Now there are no horizontal asymptotes on these ones, so don't worry about that part. Alright, try this one though. Alright, let's look at number 7. How do you factor the numerator? Jack, how's that factor?
X equals negative 1, 5.
So I get x plus 5 and x minus 1 over x plus 1. The zeros are located where then, Jack?
Negative 1, 5.
Negative 5 and 1.
Yeah.
Nice job. My vertical asymptote's located where, Andy? Negative 1. So I plot my zeros. I have my vertical asymptote. And I kind of sketch my graph. And I get something that looks like that. There it is. Here is your assignment.